Anyway, let us start because maybe like people will join. So let me share my screen. So when I talk about data science, right? So most of the people, when I go and see, when I ask them what is their understanding of data science, everybody think like data science is a technology, which is not correct. Data science actually is a field where you will have some set of systems and processes that will help you to extract a knowledge or insights from the raw data. Raw data means whatever the data which we receive, that is not a ready-made data, right? So any data. So if at all I want to extract some meaningful information from that data, that is where data analysis or data science will come into picture. Even the data, whatever we receive, will be sometimes will not be in the same form. When I talk about data form, in the sense like we receive the data in the form of files, and sometimes we also receive the data in the form of like a database tables, where you'll go and see most of the data will be will come from structured format in rows and columns, or Excel files or CSV files. Sometimes your data will be even in the unstructured format also. So unstructured format means, anybody have any idea what is unstructured format by any chance? What is meant by data in unstructured form? Structured means which will have rows and columns. Anyone have idea about what is unstructured data by any chance? Image is a unstructured data. Video, document, all this will fall under unstructured form. We cannot store a image or a document or a video in a database table because they are not structured format. Databases are designed to store only structured data. Any database like Oracle, SQL Server, all these databases fall under relational databases, which we can store only in the form of structured format. And there are databases for storing unstructured data, which are like we have like MongoDB, Cassandra. These databases are designed to store unstructured data. So when as a data scientist, I should be able to extract the data from any kind of data. It can be structured data like a database table, or it can be like a, there are other types of data formats also called semi-structured and quasi-structured also. So semi-structured means the data will be like XML files, or it can be a JSON file. So do you guys have idea about XML files and JSON files or no? Madhuri,
Yes.
you
Yes.
know, right?
Yes.
How about others? You know, right? Do you know what is it like XML file? You will have a XML tags. Raghu and oh yes. So this will be like semi-structured data, we'll call it as. Sometimes you receive data in the form of quasi-structured data. So quasi-structured means whenever you visit any website like Amazon, all your activities in that website will be tracked and stored in a web log file, a text file, which pages you visited, which products you selected, and which products you moved to cart but you have not purchased. So they will capture all these activities. Every website will capture your activities. So that data which they capture will be called as quasi-structured data. So quasi-structured data also, sometimes as a data scientist, I need to analyze. And unstructured data also I definitely need to analyze, because nowadays even image also people calling as data, video also a data. We have applications which are already available in the market, which will be helping in extracting images from videos. So many AI applications are available in the market. You go to any Google store itself, you'll find so many AI applications where we can go and extract images from the videos. So this kind of data also should be analyzed, and your data science will help you to extract the knowledge from this data. And once after we receive the data, we try to utilize it for our analysis. So how we are going to extract that? We use statistics, sometimes use data mining and predictive analytics to extract this information and get some insights, and you'll take some appropriate decisions what to do next. So data science will help you in all this particular area. So if you go and see, most of the people have a question like, why companies moved to data science? What is the motivation for data science? So there are many reasons for data science motivation. Like for example, if you see, most of the data will come from all these data devices nowadays. We'll get the data from cell phones, mobile phones, MP3 player, e-books and cable setup boxes, ATMs, credit card readers, computers, internet. So there are many sources which are generating data. And all the data, there are companies who will only deal with data collection, and they will aggregate or combine them, integrate them, and they will even sell the data. Data companies like Nelson, Morningstar, Worldcheck, their business is data management. So they will go and collect the data from different data sources, like all the sectors, like government sectors, medical sectors, internet, retail, financial, and every domain, from every domain they collect the data, and they will try to integrate them, and they will go and sell the data to the buyers. Or if you go and see, most of the credit card companies, financial institutions, telecom companies, they buy the customer data. So they will buy the customer data, and they will try to reach out these customers for telephone numbers or mobile numbers, and they'll reach out and they'll offer their products like credit cards, home loans, personal loans, all this. That is how our contact numbers will be available with the telecom companies or financial sectors. India it is very common to go and see. Every telecom company will buy the data. Every bank will buy the customer data. So here, data companies, the responsibility here is to collect the data and then analyze it, and then collect the data and then integrate it, and then sell it to the buyers. That is how data has been, companies is like buying, and whatever the company will buy, they use the data for their company growth. They will try to get the customer data, and they will try to analyze these customers. For example, Airtel will buy customers' telephone numbers, and they will try to use the data to reach out the customers and acquire them as a customers. I may not be a customer to Airtel. Airtel will reach out to me and they will offer me some products. Then if I'm interested, I'll go and subscribe and I'll become a customer. So they will try to do this kind of activities after they get the data from the data companies. Every bank also will collect our data, and they will reach out to us, and they will offer credit cards. Once you go and apply credit card, you will become a customer. This will happen with every domain. Every domain is using data science. They use data science to analyze our behavior, and according to our behavior, they will provide promotional offers or recommendations. You might have observed some recommendations in Amazon when you buy any product. So that is also data science only. There will be data science algorithm will run in the background, and they provide appropriate recommendations that are suitable for us based on our past purchases. Okay. When I go and see data science, right? Data science, when we see the data science, when it started, there was only structured data was there. Data science people used to utilize only on database tables and Excel spreadsheets, and they used to use a data warehouse where they used to store, and they used to leverage the data warehouse to build dashboards and implement data science on top of it. I'm talking about before 2000 majorly. There was no unstructured data at all. After 2010 onwards, there was a high data growth. So what are the reasons for that? Can anyone tell me? What were the main reason for high data growth? Any idea? Major data growth. Raghu, any idea on that? What is the main reason for high data growth after 2010? Madhuri? Any idea what is the main reason for data growth? You can guess and tell me. I need not I do not need any correct answer. You can tell me.
Because of e-commerce application?
E-commerce applications, for some extent is correct. Can we say like social media? Because we got so much social media applications have been built after 2006, 7, and 10, right? We got like Facebook, we got Twitter, we got Instagram, YouTube, WhatsApp, LinkedIn, and every person will have a mobile, and every person will have a Facebook account. They will upload videos and images. And before that, there was no this kind of applications, right? To upload videos and all. So that is what the main reason for one of the high data growth, one of the drivers for big data. Medical images. If you go to any hospital, they will go and generate scanning reports, digital images, and whatever, as I was mentioning, like uploading the videos and images or photos into the internet by using Facebook and other Instagram, Twitter, all these accounts. And some companies, they use video surveillance. Like even if you go and see criminal department, they will try to generate so many videos to track the suspicious people. And mobile devices also one of the main reason. Everybody will have a mobile. They will have text messages, phone calls, and also like applications, data. Many information will be there. And smart devices, smart electric meters also became one of the source of the big data. If you go to see any electric smart meter, it will go and generate some data. And non-traditional IT devices like credit card readers, point of sales readers, all these also are the drivers of big data. The data science got fame only after big data came into picture. Before that, there was no that much fame for data science. Only after 2010, the main data science growth has happened. Even I switched to data science in 2014 only. Before that, I was a big data engineer, and then I worked for in ETL for some time. And when I started my career as a database developer only. I moved to data science only after big data came into picture, and from big data I moved to data science in 2014. So 2012 to 14 was very huge demand for data science. Even now, so data science is like became very hard skill after 2012 only. After big data came into picture, everybody started like working on data science, and data scientist role became very like hot in the market. And these are all the drivers of big data. If you say, as I was talking about, if you go and see 1990s, we were only having Oracle and SAP, only these tools, and data was also only RDBMS, like tables, rows and columns. And to data was measured in terabytes. And if you go and see in 2000s, we got some kind of like digital asset management and MS Office, like PDFs, documents, all this came into picture. Then slowly from 2000 to 2010, there was data growth 2 petabytes. After 2010, the same reason as I mentioned, like YouTube, WhatsApp, Twitter, Wikipedia, Facebook, many applications came into picture, and slowly growth has been moved to exabytes. Now in 2020 onwards, it went to too high, zettabytes also. So whenever the data has been grown, the tools also has been increased. Many tools came to the market, and even the data, as I was talking about, like it is divided into structured, semi-structured, quasi-structured, and unstructured. These are the 4 types And I should be, as a data scientist, I should be able to analyze any kind of these 4 types. I should definitely need to know how to analyze all these types. The structured means, as I mentioned, majorly traditional RDBMS and CSV files and Excel files. All this will come into structured data, where data will be stored in the form of rows and columns. And coming to semi-structured data, it is just like a not 100% structured, it's a partial structured, where you will have like XML files, JSON files will come into picture, where the data is in the semi-structured format. And coming to like quasi-structured means the same thing which I mentioned, weblog files, which is also called as clickstream data. When you click on a website and log into or open a website, and your activities will be stored in a text file, which is called a clickstream file. And unstructured data is nothing but where data will be, which includes text documents, videos, images, and also like PDFs, and even voice also will be unstructured only. Nowadays, even voice also people are considering as a data. They are analyzing the voice also as a in the data science part. And when I talk about BI, business intelligence and data science, some people will consider BI as a data science, which is not correct. Business intelligence is just like a intelligence that will help you to like take the past historical data and explain that what has happened in the past. Maybe last month data, I have sales data. I will say like I collect that data and I can go and use that data and build a dashboard, and I can explain like what was my sales, what were the sales my sales last month. But coming to data science, it is more than that. We can even go and answer questions like by using the current month sales and past month sales. I can predict what will be my sales, what could be my sales next month in advance. Maybe this month I have a sales of like 80%. Next month it can be 85%. So that I can predict. That is called data science. So data science is always not business intelligence, it is a artificial intelligence. I hope you people are able to follow. Any questions till now from anyone? Madhuri, Raghu, and Tobias? Are you guys able to follow?
Yes.
So any questions
Yes.
you can ask. Please ask if you are not able to follow. Okay?
Okay.
Okay. Now, when I talk about data science, right, you need to understand about data analytics as well. So what is meant by data analytics? Whatever we do by collecting the data, we do like descriptive analytics, we do predictive analytics, we also do prescriptive analytics. But we should understand what are the difference between all these three. When I talk about descriptive analytics, right, this is nothing but the business intelligence only, where we go and generate some dashboards by using the past data, last month data. So I can use a tool like Power BI or Tableau or ClickView, and I can go and collect last month's data, and I can go and use like some kind of aggregations and data mining techniques, and I can simply go and build a dashboard and answer what has happened to my sales last month or last year or last 6 months. So I can go and answer these kind of questions. But when I talk about like predictive analytics, right, here we are going to use the statistical methods and some forecast methods, and we'll try to understand the data and will won't answer what could happen to my sales next month. The current month my sales are 80%, and my next month my sales can be 85%. So I can predict it in advance. Or I can go and predict whether a particular person is a loan defaulter or not while approving a loan. So that I can go and approve or reject the loan. Or I can go and predict the house price. What will the house price of this criteria? Number of bedrooms 3. Age of the house is 10 years. The price can be 1 lakh. I can even predict it. So data science will help you here. Predictive analytics will help you. What could happen in the future? What could be my house price, or what could be my sales If we go to manufacturing plant, which machines will go down? So all these are part of predictive analytics. And we also have prescriptive analytics. This will utilize optimization and some kind of artificial intelligence, and this will answer the questions like what action to be taken, what should we do. I'll give an example for descriptive, predictive, and prescriptive. Let us take an example of manufacturing use case. So manufacturing company, if you go and see, in manufacturing plant, there will be so many machines which will be producing some products. Correct, right? Do you people agree? In a manufacturing plant, there will be so many machines will be running to produce, so or in the manufacturing process, they will produce so many products. So if at all I want to find out which machines went down last month, then I can go and collect the information from my database. I can go and build a dashboard and explain which machines went down and what are the reasons for that. So that is called descriptive. We won't use a dashboard for that, and we will plot and will show like these are the machines went down and these are the reasons. And when I talk about predictive analytics, the same case, we'll go and see and collect the past data, which machines went down, and I use that data and will predict which machines will go down next month or next week. And that is called predicting. We are predicting for in advance for the future. So that is will follow, and after we predict, what we'll do, we'll try to see which products went for a defect, and we can go reach out the vendor and come and replace it, and so that my machines will be run again, we restarted. And prescriptive analytics is furthermore, which is like where we go and use the past historical data and we predict which machines will go down and what action to be taken on the machines which went down. So immediately I can shoot an email or message to my vendor to come and replace the defective products. In the predictive analytics, we do that manually by reaching out to the vendor. But in prescriptive, even my model itself will go and predict, and it will also send a notification to the vendor to come and replace. So we do not need to involve at all. Everything will be automated. So artificial intelligence and deep learning will fall under prescriptive analytics. So we have descriptive analytics, predictive analytics, and prescriptive analytics. All these they are very, very important for a data scientist to understand. Even data analyst also. So predictive and prescriptive are the very, very important analytics which we need to understand compared to descriptive. And what tools we use in the data science side to implement this particular data science? We use Python. R programming also is there, but people are not using R at all now because R became obsolete. But Python is the common language which will help you to implement data science. And there are some distributed machine learning platforms also where Hadoop, Apache Spark, and H2 will help you to build machine learning algorithms in the distributed environment. If the data volume is high, I definitely need to use the distributed platforms like big data. There I need to depend upon Spark and H2O, such kind of tools. And as part of our training, we are going to learn Python and machine learning, and we also learn a bit on Spark also. And as a data scientist, I should also understand what is data mining and machine learning as well. So when I talk about data mining usually is a process in the data science that will help you to analyze the data which we receive and will summarize it into useful information, where that information can be used to increase the company's revenue or reduce the cost, or sometimes both. Every data scientist responsibility is to use the past historical data of the company and summarize it and build a analytical model, ML model, to predict the future, which will help you to increase the revenue of the company or reduce the cost, and sometimes it should help us in both. So data mining software like Python and Excel, all these kind of softwares will help you to analyze the data which we receive from the customer. And what about machine learning? So machine learning is also a type of artificial intelligence where it will provide the computers an ability to learn without being explicitly programmed. So it will learn from experience, not from the like how we learn. A program will learn from the data, and it will focus more on the development of where computer programs will teach themselves. How I am teaching you, and you are trying to learn from me. But there a program will learn from itself, and it will try to behave according to the new data. Maybe I for a ML model, I'll go and pass all 100 house prices with all the details. Then it will remember all the house prices and what are the factors for that. When I pass any new house like requirement, it will automatically predict what is the house price based on the past historical data which I already passed it to the model. So like that, machine learning will help you to predict the future. And domain wise, if you see, machine learning is getting utilized in many domains like healthcare domain, retail, insurance, consumer financials. You go and see in consumer financial credit card fraud. I also go and I'm currently working on anti-money laundering, where I use data science to predict suspicious transactions in money laundering. And if you go and see in retail side, you will companies use to predict the out of stock of products. And some companies use like to find out the best location for their new stores. And there are some factors that will impact, that will influence. So we need to find out the factors and market basket analysis. So this is one of the common use case which even we experience. I want someone to tell me when you go to supermarket, how many times it happened you went to buy one product and you end up with buying full of basket. Madhuri, how many times it happened you went to buy one product and you came back with full of basket?
So many times.
that
Each time,
will
every time
happen.
I go for
Even
shopping.
I too did. Everybody will do that because there is a supermarket strategy in the background. They do use some kind of machine learning in the background. Nobody knows it because there is a algorithm called market basket analysis in machine learning. What it will do, it will generate a frequent combinations of the products which customers bought earlier. For example, when you go to supermarket, there is a probability that people will buy two products together, like bread and milk. Correct, right? Sometimes people buy, and some people buy like even they have kids, they will buy like chocolates and biscuits together. They buy like if there is a just born baby is there, they will buy like diapers and wet wipes together. So like that, see, they keep some products together and they will keep some discount on that. So when you go to supermarket, even if you don't require it, if you find any discount on that, immediately will go and place it in your basket. So that is how supermarket will analyze the customers. So they will, even if you go and observe any time, any supermarket, you will not find any clock. So their strategy is you should spend more time in their supermarket, and you will go, if you see, you will enter in from one like one side and you will exit from on the other side. So that they how they will like construct the supermarket is you need to visit the entire supermarket. So that is how they will try to keep the exit and entry. They do many things to analyze the customer. So they keep some products near the point of sale also, so that you'll whatever you forget, you'll immediately pick up and you'll put in the basket. They don't even leave you, even at the like billing counter. Correct, right? Even at the billing counter, you'll find some products, no? Yes or no? Like
Yes.
they'll keep some kind of batteries, which usually you'll forget. Small items, and you pick up that you'll put in the basket again. Even I do that. See, everybody do that because as a human nature, you find anything and you feel that even it is not required, you sometimes you will do that. That is because of this kind of strategy which used by the supermarket. On the manufacturing side, which I was mentioning, predicting the downtime of a machine, what are the machines went down. And if we go and see life insurance domain, companies do data science to find out which are the claims the customers are going to predict next month. And coming to logistics side, they will try to use data science to find out the best route to reach out from source to target location. And also, if you see like healthcare side, they will use in the medical fraud and also some patient survival analysis. They do use data science for that. Whether a particular patient is going to get heart disease or not, they'll try to analyze it. And the construction side, they use to predict the design issues in the a building plan, for example. In the travel domain, also the air companies, they use aircraft companies, they use for aircraft scheduling. And seat and gate management, they use to optimize the seat and gate management, they use data science. And energy utilities, if you see, most of the energy utilities companies, they use in the smart electric meters and automatic AC frequency controlling. All these are part of data science only. And finally, life sciences domain is one of the domain where data science was people using for a while. Pharma domain, they are using data science to test their drugs. So drug demand, whether a particular drug is going to cure the disease or not. These kind of use cases, they use data science as part of this particular each domain. So any questions till now? You can ask. No questions? Are you guys clear? What is data science and why companies are using data science and the motivation for data science and what tools we use? Python is the programming language which we learn as part of this training to implement data science. That's a very, very common and very demanding language for data science or data analysis as well. And coming to what we are going to cover as part of this training. So let me show you. We are going to learn as part of this training, we are going to start with what is introduction to data science, and we'll also go and learn about there are many things which we go and learn as part of the introduction. What is machine learning and what is deep learning, and what are the roles and responsibilities of data scientist in any project. And then we'll try to understand the end-to-end data science lifecycle, project lifecycle. Plus, we also will understand what are the different data science applications and what is predictive modeling, what is classification, what is regression, anomaly detection. There are many different techniques are there. We are going to understand about each technique at high level. And once that is completed, we'll jump into the tools which we are going to use for data science. There are many different tools in the market, but we are going to learn about Python extensively because Python is the common programming language for data science. We are going to learn about Python, and before that, we also will learn about a little bit about statistics. Because every data scientist should know a fundamentals of statistics. We are going to learn about what are the different types of data, like what is the ordinal variable, nominal variable, and continuous and discrete variables, and categorical data, and what is time series data. We are going to learn, and we also will learn about the fundamentals of measures of central tendency, like mean, median, mode, range, and also we learn about standard deviation and variance, all this. And we'll also learn a bit about probability distributions and what is sampling and what are the different types of samplings available as part of this. And we also will learn about inference statistics and hypothesis testing and correlation and what is linear regression and all. We also learn after this, we learn about a bit on SQL part, which are going to cover MySQL. And once we finish that, we'll jump into Python. So Python programming, we'll learn from fundamentals, and we also will learn about the advanced Python, like where we are going to learn about NumPy, Pandas, Seaborn, Matplotlib, and we'll also do some like learning on EDA, what is meant by EDA and how to implement that EDA using like Python, Pandas, and Seaborn and Matplotlib. And we also will learn a little bit about like what are the different data preparation techniques as part of this. And we are going to learn about all the data preparation techniques here: feature engineering, feature selection, and transformation. And we also will learn about like categorical encoding, handling missing values, and cleaning the data. So all this we learn as part of this particular module. Then once we finish that, we jump into machine learning, the actual machine learning. We'll try to learn the introduction, what is machine learning and how it is different from statistical modeling. And you'll learn about each and every algorithm with example as part of this particular training, because we should understand which algorithm is required for a particular use case. Supermarket, what is the algorithm? I'll say like market basket analysis. House price prediction, I need to use linear regression. For loan defaulter prediction, I will use like classification algorithm, logistic regression. So like that, I should know which algorithm is suitable for which use case. So we are going to learn each and every algorithm one by one, like linear regression. We also will learn about nonlinear and logistic regressions, and we also will learn about how to go and validate the model and deploy the model. And once we will finish that, we'll jump into other algorithms like decision trees, and also we'll learn about bit on tagging and random forest and boosting. And once we finish that, we'll jump into like gradient boosting and light GVM and XG boosting. And once these are completed, we'll jump into like nonlinear algorithms like supported machines, naive Bayes, and KNN. All this will fall under supervised machine learning, where we know what to predict. And then we'll jump into unsupervised learning, like clustering and association rule mining are also called as market basket analysis. We are going to learn as part of this. And once we finish that, which we'll jump into deep learning. We'll go and learn about what is deep learning and what are the different types of algorithms fall under deep learning, like artificial neural networks, recurrent neural networks, and also like convolutional networks, all this. And once that is completed, we'll jump into like NLP, natural language processing, text mining. The text mining we are going to understand about what are different techniques available in text processing and text modeling. And finally, after we'll finish this, we also will learn about what are the different methods to deploy the model. So building a model is not like only the job of data scientist. As a data scientist, we should know how to deploy the models also. Even companies are looking for the people who know the deployment of the models, because model deployment is one of the key step in any data science project. If you don't deploy it, client cannot use it and you will not get money. So model deployment we are going to learn in detail. And once the model deployment is finished, we'll jump into data visualization like Power BI. We are going to cover in detail, and what are the different features of Power BI and how to connect with data and how to go and create dashboards and all. Then we'll jump into Azure Datalakes storage and data factory as part of this in the 13th module, and we'll see how to manage the data pipelines using data factory. And we also will learn about Databricks, which is also an important cloud like a data platform, and we need to understand about Databricks and how to implement data science using Databricks, where companies are looking for nowadays. And once that is finished, we'll jump into some projects, end-to-end projects, to implement all what you learned from this training. So apart from this, I want to even discuss about a little bit upon like what the IT talent hub is, like the companies, institutes, like what they are doing as a company. So IT talent hub is a like is a independent community in the UK, which is like providing the services since almost more than 10 years in London, and the office is located in Ilford, UK, which is very easily accessible to the our learners, and which is nearest to the Queen Elizabeth line and accessible anywhere in London. And we have a dedicated recruitment team who will support our learners in every stage. We have a dedicated team who are responsible for this, and they are very actively like support the teams. And we have a community of 1500 believe community already, who are the past students and who are current students and who are part of the community. As a community, we also provide like training, networking, and recruitment, where we'll go and provide all these services. And we have the clients also are in Department of Education and Cockrio and London General Practice, Transform, Test Partners, and MIC. All these are like well, some of our clients. And coming to like we have some people already like learned, got some training, and already got placed in some of the companies, where you can see here. And we can also be a part of this particular like a success story. And why we need to go for IT Talent Hub is like we have the IT Talent Hub has top quality trainers. I am the person who is responsible for data science. I'm already giving data science training for almost more than 3 years. I like delivered more than like 30 to 40 badges, because so I trained many people. So I'm still giving trainings, and I do training is my passion, and I train people where they are interested in data science more. And that the curriculum also which I designed, this is as per the UK job market, and where we already placed more than 10+ students even in last month. And we also have a exclusive job support program to help the students after the training. Once the training is completed, we have a separate job support batch, and we also provide the like the links and the top consultants and companies in UK frequently, and where a dedicated recruitment team is there to place the students. They will interact with the students, and they will go and collect the information, and they will support the team, the students, and they will guide in each step. And we'll provide a live projects with some of the startup companies, and the interview preparation sessions will be there, like mock interviews will be there, and certification also will be provided after the training. And we also have a job placement support after the training, where you'll have a like end-to-end CV preparation support and real-time project, and also interview support. Whenever you got an interview, you'll have a dedicated session where you will have a session to interact with me, and where I will guide you what to do as per the interview, how to go and like prepare for the interview and all. And I'll provide some technical tasks also. If any technical tasks are there, you can even take a guidance from me. And we do like training not only on this particular like data science. There are other batches also, like DevOps and testing and AI testing, all this stuff. And the placement support also is available, like where you whenever you want any guidance on placement side, you can reach out the like recruitment team. They will guide you on what are the steps to be followed. And the training will be like 2 months, and you will have a live project for 1 month, and you have assessment, and then you will have a job support service also. This is what the job support approach, which you can like understand. And job support services, like where I'll provide a client project, and where once your project is completed, the recruiter will help you to get the jobs from the companies, and they'll also help you to like in the CV preparation, and they'll provide the like list of jobs to be like applied and all, and where you need to apply, and you'll have a marketing agent who will support you. And once you have interview and project like project is like interview is set up, you can reach out me with the guidance of the job support team, and we can have some session, 1 or 2 sessions to like understand and prepare for the interview where I'm going to support. And that's about the process